Yeah,
Can you see my
that's fine.
screen?
Yes.
Okay.
Mm.
Um, so good morning, good afternoon, everyone. I'm
Good
Julia Atayi, a past student of Professor Amos Kaboba. So I'm excited to be part of the Maidens Climate Change Conference hosted by the University College of Water Science and Engineering. So today my presentation is on unveiling the urban flood dynamics, which is a comparative study looking at the spatial rainfall patterns and the flood model output. So this study is on one of the cities in the US here. Mm. One of the cities in the US here. So before that, I'd like to talk about some terminologies that was used in this study. So first is the pluvial urban flooding. So as the name sounds, urban flooding, meaning that a type of flooding that happens in urban cities. So this study is very important for this conference because it will help compare some of the information that are happening in the developed countries and what's happening in the developing country. So pluvial flooding has been increasing mostly in urban areas in most developed cities. And now flood modeling helps to understand or assess the flood condition that's happening within the city. And there are several hydrodynamics models that have been developed to understand the flood conditions in diverse means. And these models are mostly either commercial or open source type of model. But for this study, the type of model that was used is an open source tool. So the city that this study was conducted is one of the watershed in the city of Baltimore, and is currently facing a frequent flooding due to the effects of climate change and urbanization. And this severity varies across different areas due to the land cover change, surface impermeability, and inadequate drainage infrastructure. And most often, when this type of flooding happens within this area, the marginalized communities or neighborhoods are often hit by the hardest due to infrastructure inequalities and limited access to resources. So what I mean by marginalized neighborhoods are like people who don't have like are limited with certain resources in terms of finances and access to transport and access to other amenities. So this is the map of the study area. And this city specifically is hit by the different types of flooding, ranging from the riverian flooding, pluvial flooding, and the tidal flooding. So the watershed that was focused on is the one with the blue boundary. So this is the model that was used for this study, and it's called CityCat, the City Catchment Analysis Tool, and it's an open source tool which was developed by some researchers in Newcastle University in UK. And the data inputs that is required for this model are digital terrain model or digital elevation model. But it's advised that to use this digital elevation model, it has to have a high resolution. It must be a high resolution. So it's preferred that it has to be either 1 meter or 0.5 meter resolution. And we use the impervious surface area. So it's what's because this type of study is focused on urban flooding, meaning that urban areas which have less permeability. So we use the building shapefile. So with the building shapefile, what it does is when it rains, typically, you know that when it rains, the water moves around the building, but does not unless on worst case scenario before the water can penetrate into the building. So we use this to mimic the what's happening on ground, and we use different soil data. So we use the soil data, and the soil data helps to know the type of different infiltration rates. So you know that when you look at on ground, one soil type may be different from a different area or having a different soil type. So like this is like a real ground modeling scenario thing. And we use a historical rainfall. And with this type of rainfall that we use for this study is a radar rainfall, which is a 1 kilometer by 1 kilometer, and records every 15 minutes. So I'll talk about it in the next slide. With the data analysis method, we use the green ant method, the building hole approach. And as I was saying, the building hole approach, it mimics that when it rains, the water is rerouted around the building, but it doesn't penetrate in. And the 2D shallow water equation helps to know the rate at which the water is going to flow in terms of the velocity, the speed at which the water is going to flow. So with the validation, there are other that means that people report their flooding issue. People report through Twitter, Instagram, Facebook, 311 and 911. So we use that to know whether our model is it's what's happening on ground. And the model output is presented in flood map extent and in animation form. So as I was saying, the radar data that was used in this study is for this rainfall study is a radar, and it's a 1 kilometer by 1 kilometer and it's 15 minutes. And this was analyzed using a hydronext bias correction method. And this data spans from 21 years. But this type of data, because the analysis was quite complex, the team that analyzed this radar data, they focused on mainly the season that's rainfall is recorded. So in the US here, most rainfall are recorded within the summertime, that's from June to August. So this is the period that the rainfall was recorded for that. And study shows that even though there are high rainfall that is recorded within a city, the intensity varies. So this is the digital terrain model that I was talking about. So for this watershed, you could see that the upstream have a higher elevation as compared to the downstream. So even just looking at this map, you could see that ideally when it rains, it's going to drain downwards most often. But I wanted to compare and see if there will be a variation in that, just not looking at this model to just draw your conclusion. So this is the spatial temporal variation of the rainfall that was recorded. And these are the months that recorded the most highest rainfall within this watershed. So we looked at the one that recorded the least time. So from 3 hours, and we look at 12 hours season, 22 hours and 6 hours rain. So you could see that for the May 28th, 2010, you get that most of the rainfall, that's the blue color, recorded a higher rainfall upstream as compared to the downstream, and this varies across the various periods. So these are the flood model output. So though even when you look at the rainfall period, you could see that most of the rainfall recorded upstream as compared to the downstream. But looking at the elevation slide that I showed previously, you could see that most of the water drained down to the side. So the red area shows, per the model, the red area shows the areas that were flooded most, and it varied across the highest rainfall intensity that was recorded in the city. So this is for the previous model results too as well. So this particular area, which recorded the highest flood, it's a major problem within the city. And in 2020, it was recorded that a bus was seen floating within that area. So this is a bus that was floating within that intersection there. And this has been one of the priority areas for the city to investigate to see if there's a need to increase the drainage size there or do other means to help reduce the flooding that's recorded there. And mind you, there are buildings in there, but unfortunately, those people staying there are a marginalized community. So that means that there's a need to either increase the drainage or do a green infrastructure that's mimicking nature within that area. So this is the animation of how the model, the flood records within a 22 period. So you can see that when it rains, all the water draining up and it's building within this downstream here. So after the 22-hour from the model, this is how the water is built up within the area. So that means that there's a need to carry out interventions there. So in conclusion, this study highlights the importance of integrating advanced hydrological model, high resolution meteorological data, and GIS to enhance the accuracy of flood prediction. Also, flood modeling helps to understand what's happening on ground, both short-term and long-term planning. And also, there's the need to advance modeling technique, incorporating interdisciplinary approach to help build more resilient urban environments to withstand extreme rainfall events. So the next step for this study is to incorporate integrated approach, that's combining flood model with socioeconomic data. So looking at when flooding happens within the city, which people are mostly affected, is it the poor, the rich, or which kind of people? And also look at the climate change scenario. So looking at the present climate change scenario and a projected climate change scenario to help sustainable urban flooding. And also what's currently happening in the US here is look integrating green infrastructure. So in green infrastructure, what I mean is integrating trees within urban areas to be able to help in the infiltration rate. So we are going to change the soil characteristic. And also what was realized in the model was that the area that recorded the highest flooding were the areas that had the clay type of soil. So that means that infiltration within that area will be very difficult. So yeah, that's the references that was used in the study. And thank you all for your attention. Hello.
Great. Thank you so much.
Okay, thank you.
Good. So the next person,
Hello, Prof. Just
yes.
to mention that Susanna, who was supposed to present earlier on, said she had technical challenges, so she